Good morning, everybody. How are you doing this week?
Good.
Yeah, good.
I want to thank Charles real quick. So Charles sent me the Python workbook he put together last night with waste by licensee by day, which is the exact data point that Better Carbon Solutions has been searching for. And I think it'll be helpful for anyone who's interested in cannabis waste. And I think we were talking about last week how perhaps people in other states could even look at Washington and learn from us. So it could be helpful to waste producers in other states as well. So good work there, Charles. Do you have any comments?
So, definitely take a look at it and see how you want to display that. There's over like 1,100 different producers that produced waste. And so I wasn't sure how to display that.
Well, I would just start with just average. So just what's the average amount of waste per licensee per day? And so I would maybe start there. So that way you can just get a singular time series. You could look at like the top 10, see what the top 10 producers, how much waste they're producing. And then this one, you didn't really need to sort it by licensee, but it would also just be interesting to look at total waste by day. So.
Okay.
So those are the three metrics that I would start by plotting, and then those are just all time series, so you could get more creative than that, I'm sure.
Okay. All right. Well, I'll keep plugging away at it.
Ooh, speaking of getting creative, so one of my favorite types of figures is a map. So you could potentially have a map and have almost I'm not sure how you could do it. I wonder if you could almost do like radial sizes, so you just have bigger circles around the bigger waste producers. But I'm not sure if that would really make sense. But that way you could almost get like a geographical sense of where all the waste is.
Yeah, maybe like a heat map of a region.
Exactly. A heat map would be a good one if you're feeling ambitious, but you have the data, so it's possible. And if you need to geocode the addresses, Canlytics has a little utility helper that for the most part you can just toss in someone's name, just their licensee name, and it can get you the geocoded address. Okay. But anywho, good work there, and I think how about maybe I'll take a look at that. We can digest it, and then if you want, we could look at that. Look at your waste data next week.
Okay.
So that's awesome. It's good to see you here too, Nick. I've actually got something interesting for today. So last week we started looking at the inflation of cannabis prices in Oregon. So finished compiling that data. So let me just go ahead and push it up to the Cannabis Data Science repository here. And then I will go ahead and start showing you just a bit of the progress that I've made on calculating inflation rates since last week. So, little Don't worry, Charles. Didn't miss anything. I'm just opening up the presentation. All right. All right. So it is actually April 21st. However, this is essentially the presentation I put together last week. So Charles has seen this. Nick, I'm just going to run through this real quick just so that you can get up to speed with the data we're looking at and the stats we're trying to calculate here. So we're looking at total cannabis sales in Oregon, and we can break that down by product type. And this is available through Oregon's public data dashboard for the cannabis industry. And they update their data quickly. So you have everything through the prior month. So you have everything up through March of 2021, which is phenomenal that they publish their data so quickly.
Yeah, did they fix that dashboard? Because last time I checked, it was like I always had issues, but maybe I had just the wrong link. But like it would always just air out and nothing would show up. So that's
Yes. So the dashboard is a little tricky. So it when you access it, it's actually an HTTP address, and you may have to hit the advance, proceed to an unsafe website button.
okay. All right.
And so it may look like the website's unavailable at first, but essentially, I think they're just running on HTTP, and then most, modern browsers, warn you against, navigating to some HTTPs.
It's worse than that. It means that they're running HTTPS, but they have a self-signed cert or one that can't be verified.
Oh, thanks for chiming in. So exactly. So it's good to hear from someone who's, knows their computer science. So thank you for chiming in. So maybe proceed at your own caution, but in this case, I went ahead and collected the data because the data is valuable in our case.
Yeah.
So, and the other thing is, you may figure out a niftier way. So here I'll show you what the data portal looks like. So as we've noticed, it's not secure, but we're not posting any sensitive data here. So long story short, you can download some series, but some series it's hard to download. So I actually transcribed the figures, and I put them here in the. Well, I may have saved. Oh yes. So essentially, I've just transcribed the numbers here into Excel. So you can double check my work and that I transcribed everything correctly. But if you can think of a niftier way to collect this data, then by all means, have at it. So back to the presentation. So we've collected sales data. We've collected price data. And we're curious about inflation of prices. So, of course, you notice right off the bat that prices in the first 2 years decreased dramatically, as you would expect in a new market. So as things are coming to equilibrium, as people are figuring out how to price their products. And then you notice in the longer run, prices seem to stabilize, and you have steady it appears that you may have steadier inflation at this point. And so that would just be, a moderate increase in prices over time. And then we've noted that economic theory would suggest that sales and prices would be correlated with the interest rate. Notice the cannabis industry is a little unique, so it may not be as strongly correlated with the interest rate as other industries may be. And so we're just going to see if the interest rate can be helpful to predict inflation in the cannabis industry or not. So here you see the interest rate is lower to, near zero in early of 2020. March of 2020, to be specific. Well, maybe February. Next, we're going to try to estimate output, inflation, and the interest rate. And just for a reasonable timeline, we'll just do through 2022. So just for the remainder of the year to see what output and inflation may be in Oregon this year. So we are using economic theory. However, the statistical model is atheoretical. So it's really just taking any vector of time series and using historical observations to forecast that data forward. It's useful because you can apply it to really any time series data, and as long as it's coming in at a regular interval. So you can look at daily data. If you're looking at actual individual transactions during the day, there's statistical problems there. And then the other major pitfall of vector autoregressions is, of course, if you look at our equations from earlier, you'll see that there are a lot of variables. So sales depend on sales from however many periods ago. So they may depend on 1, 2, 6 periods ago. Likewise, it also depends on inflation from 1, 2, 6 periods ago, n periods ago. However many lags are in the model. Similar for inflation. So if you only so in this case, we're looking at monthly price data. So we're just looking at the number of months really between 2017 and early of 2021. So we have about 50 observations here. And so we're going to be chewing through our degrees of freedom quite quickly. Because if, say, you just had one lag, then in this first model, you would have, 4 parameters times 3 models. So that would be, 12 parameters with just one lag order. So with 50 observations, you probably couldn't estimate the VAR with a lag order of 6. You probably would not have enough observations. So keep that in mind when you're estimating your VARs. So that's why monthly data can be a little tricky. Weekly data is nice, and then daily data has its advantages because you get a lot of observations. And my only observation is it depends on your forecasting horizon of which frequency you want to choose. This is just a slight note that just says that we don't actually think that. Well, essentially, we're just saying we think that people essentially take the interest rate into their calculations when they're making decisions. So the Federal Reserve can, change it, however they want. People are just going to change prices and act accordingly. So enough of that. Let's go ahead and get into forecasting. So real quick, just to run over the 10. So these are essentially Professor Iqbal at UNC Charlotte just told me these 10 steps to forecasting, and they proved pretty useful as 10 steps to follow when you're doing forecasting. So first, we need to know what we're forecasting, the inflation rate in Oregon, cannabis prices. We need to understand why we're forecasting, because we want to know how prices are going to be moving in Oregon. As we've saw, it looks like there's going to be moderate inflation, but we want to actually quantify that. Then we need to acknowledge the cost of the forecast error. So that would just mean we can't, take too much stock into our forecasts. So, what's the cost of overestimating inflation and what's the cost of underestimating inflation? Because, if we put these forecasts out there and businesses make decisions about them based on what they think prices may be, they need to take into consideration what's the chance of overestimation / underestimation. So that's a tricky one, but important to take into consideration. Next, we just need to know the horizon, which we're just going to be forecasting through 2022. Long enough to be useful, however, not too long that it's unrealistic. We've chosen our variables. Inflation, output, and the interest rate. And we've chosen them because of economic theory. We've then chosen a vector autoregression to do the statistics. And that fits our economic theory, and it's a simple, relatively simple statistical model that we can also use for forecasting. We'll want to present the results in some sort of figure. I'm not sure if you've heard of Edward Tufte, but he would always emphasize that you need to show the data in some sort of beautiful figure. So we'll throw out some charts. Then we'll want to interpret what predictions we've made. So we'll want to see if inflation's rising and decreasing. What's our confidence? Next, we'll essentially want to use recursive methods. So what this means is we want to keep forecasting each month. So we'll want to revisit our forecasts next month and compare our forecasts to the actuals and see if we can't make better forecasts the next month. And when we do that, that brings us to the final step, is when we look at our forecasts next month. So we'll be forecasting April sales today. And then in May, we can actually check our forecasts and see if the model we selected was a good predictor. And we may need to select a different model if our forecasts were wildly wrong, or slightly adapt the model, or stick with it if we can't find a better model. So that's a quick background Are there any questions before we jump into the code here? All right, so I just opened up Spider here. There's nothing special about Spider. I'm getting used to running Python in VS Code. However, I'm still just faster and more effective in Spider. So until I'm better in VS Code, we'll be here. Or another editor. I've heard of PyCharm and Atom. Both seem like good choices. I haven't tried either. Your weapon of choice. Okay. So the packages we're using today are essentially numpys and pandas. And then I'll be reading in a federal thread API key from an environmental variable, an environment variable, and then we'll be using the Fred API to get the interest rate. So, first things first, we need to read in the data. So I'll just be reading in this data that I've scrounged from the Oregon dashboard. Just to look at, the first observations. Notice we don't really have consistent prices across the board until about 2017. So a professor in college really emphasized you never want to throw away data. However, in this case, just for simplicity's sake, I'm restricting the time period to 2017 and onwards. And that's for simplicity's sake. If you have a more elegant way to estimate the models, then by all means. So we're looking at data from 2017 through March of 2021. And first rule, look at the data. So what are some of the variables we have here? We've got total sales. We've got flower sales. We've got concentrate sales. I thought we had retail flower prices. Okay, so we've got retail flower prices and we have retail concentrate prices. So those are our variables of interest. And so last week we talked briefly about how to calculate the CPI. And just to show you our presentation from last week with my chicken scratch, we basically noted that the consumer's basket of goods is about 60% flour and about 40% concentrate. So if you were going to calculate the CPI, which is a price index, so you can think about a stock index, which it just sort of measures the general trend of all the goods in the basket. And so our basket is concentrates, and flour. So our CPI will be the sum of all prices times their weight. So we can actually do that here in Python or your favorite programming language. So essentially, we can calculate the share of flour out of total sales. Rule number one, look at the data. So as you see, flour was making about 70% of all sales, and it's actually decreased, which is interesting, and is now maybe kind of stabilizing around 55 or so percent. So that's quite interesting. Then you can calculate concentrate share of the sales. And so this should be roughly the inverse, where you have concentrates, because keep in mind, there are also edibles and other goods. So this is we are excluding some data here. So it would be nice to have prices on edibles, but edibles vary so much across the board that it may not be comparing apples to apples. Or infused apple to infused apple.
Yeah, that's what sucks about this is they kind of lumped everything together, like edibles and like some of that's a lot, like because the concentrate would include like oil then too, right? Like that.
Yes.
So it's a lot of different things that they put in there, and then on the manufacturing side, like we have to consider this as by retail sales. So that if we're forecasting, we have to actually like consider there's a markup, and so we're trying to get back to like what we sell it at. So it gets a little complicated.
That's a really good observation, and from someone who's in the industry, because as you noted, they're sort of aggregating everything here, and as you said, there's a wide array of concentrate goods. So you've got your everything. So you've got your really high percentage distillates to maybe just some lower percentage waxes and other oils.
Mm-hmm.
And then, there are concentrates being made and sold to edible producers, and then how do you classify something like just like infused, like when they make like moon rocks or something like that?
Yeah.
Because moon rocks would probably be technically a concentrate, but that's hardly the same thing as an oil. Okay, but taking what we have, taking our lemons, we'll try to make lemonade. So we've got the share of flour and the share of concentrate, which are actually by themselves are interesting figures. So now we can calculate the Cannabis Cpi, which will be the flour share of prices times the retail flour price plus the concentrate share of sales times the retail concentrate price. And so this, you can maybe calculate this in a more glamorous way, but that is essentially this calculation here. So we'll calculate the CPI. Let's just look at it just to see what it may look like. However, the nominal value doesn't matter too much. It's more about the trend. So the trend, we can calculate what we've defined as inflation, which is just the rate of change of the CPI. So we'll basically just be looking at the CPI. And so just to go back to the presentation real quick. So it's basically the CPI of today minus the CPI of yesterday divided by the CPI of yesterday. Last week, I just made a crude hypothesis that it would be between 1 to 3% on average, which would maybe be what you'd expect maybe in a more mature industry. So let's go ahead and calculate this and run it. And I'm actually, so it's kind of jumping across the board. The first thing I notice is it is negative, which negative inflation is deflation. Deflation from the federal level is not desirable. So deflation can have bad effects. So from a consumer's point of view, if there is deflation, then you know that prices are going to be decreasing. So you know prices next week are going to be lower than prices today. So it gives you the incentive to wait to buy your goods next week. So if everybody's just waiting as long as they can to buy their goods, then it's going to decrease, the economic demand even more. So businesses, they're already struggling for demand, and now consumers are postponing their purchases. So the businesses don't have much cash flow. And so it's even harder for the businesses. They lower their prices even further. And so you can get trapped in essentially this cyclical deflation. That's sort of bad in the economy as a whole. Like I said, the cannabis industry, it's sort of this short-term shock where things needed to stabilize. There was just this, I think there was even a note in Oregon where they're just saying, oh, there's so much supply. So just in this first few years, everyone's sort of figuring out, okay, what is the level of supply? What's the level of demand? And prices, where it appears, were just too high. Or not too high, but maybe those were the prices maybe when you were expecting more of a gray / transitioning from a black market. And then as more producers entered the market, you see things stabilize over time. So it looks like it took about 2 years for people who were thinking about entering the market to enter. So this is the time essentially where everybody's entering the market, and the people who aren't successful maybe exiting the market. And then it looks like by about 2019, things are starting to stabilize. So let's actually just look at inflation in percentages real quick, because that's typically what you think about. And then let's just look at the mean. So as a whole, prices are decreasing. I would just note that, so if you just look at the last 2 years, if you just look at the last 2 years, inflation maybe is around 0.5% per month, which is maybe that's closer to typical. So maybe moving forward, you may expect more, this slight, 0.5% a month inflation. Maybe there's some shocks here and there, but I would, personally, I wouldn't expect this deflation to continue. Right? So that's just sort of our crude data analysis. So now let's grab the interest rate and start forecasting here. So you can get your API key for free from the St. Louis Fred. They're a good resource. Just starting to try to incorporate them into my work, just to get some more data points in here. And this is the effective federal funds rate, and it can be a good starting point. And it looks like something went wrong here. Okay, so not 100% sure. I'll have to investigate what that was after this. But long story short, we've got the interest rate now. I think that was maybe some sort of error, maybe reading in my API key. Anyways, moving on. We've got our interest rate now. So this. So we basically just read in the tail end here of the interest rate. And we'll use it in our vector autoregression. And like I said, next month we can compare our forecasts, and perhaps maybe even next week we can maybe even try a different forecasting model and then compare the two forecasting models. So we could try next week to just do an autoregression of inflation, and then we can compare that to the vector autoregression and see what forecasts better, the more complex model or the more simple model. So, and that's that takes us to our our 10 commandments, where we wanted to use recursive methods. Okay, so we have our total sales, we have inflation, and we have the interest rate. We're going to toss all of these together into a vector. And so just to show you what the vector looks like. So basically, this is sales. This is inflation. And this is the interest rate in time period 0, which would be 2017 January. So this is sort of what the vector looks like. So just to show you what's happening under the hood. And so now I wrote a scrappy vector autoregression, and I wasn't actually very pleased with how it was working. So I actually noticed that you can actually just use a vector autoregression in the stats models package. So it saved a lot of time. And it's a bit more flexible. You've got more contributors, so more stable than my scrappy var model. So we'll use this one from this package. And so let's say you're just going to fit. Well, this one has my notes on it. So here's our 3 equations. So let's go ahead and fit this. So output, inflation, the interest rate. And we're just going to use one lag order. And so what we've done here is we've basically estimated 3 ordinary least squares regressions simultaneously. So this is our first regression. So this is our regression for output. Then this is our regression for inflation. And then this is our regression for the interest rate. And so as you see, each one has a constant, and then these are the coefficients. So this is beta, this is gamma, and this is delta. So we've estimated quite a lot of parameters here. I'm not sure if they tell us our degrees of freedom here, but long story short, we were able to fit an AR1, so that's a good sign. Next, if you were going to fit multiple models, so say we're going to fit an AR2, so we're now going to use 2 lags. So here are our 3 simultaneous equations. And now you'll notice that we have 2 lags of each. Yes, so 2 lags of each variable. So there's output lagged once, output lagged twice. Inflation lagged once, inflation lagged twice, the interest rate lagged once, interest rate lagged twice in all 3 models. So that is a lot of parameters. That is 21 parameters, I believe. So that's 1, right? So that's 6, 7, right? 7 times 3. It should be 21 parameters. So not sure if we can, it's going to be tough to estimate too much larger. However, we can try. But we need some way to compare these models to each other, right? Because we could just do this all day if we have a large enough data series. So essentially, we need to have a criterion. Essentially, the BIC, the Bayesian information criterion, it rewards you for making better predictions, but then punishes you for adding more and more predictors, more and more parameters. So the BIC is a useful way to measure which model may be a better choice. So as you'll notice, this model, we've tossed in a ton of parameters, so we may be able to predict a little better, but we've got a BIC of 22, and this model has a BIC of 21. And so we want to pick the model with the minimum BIC. And so in this situation, the AR1, it's more parsimonious, and it's actually the better model choice if you're choosing by BIC, because you're essentially overfitting with this model, and it may lead to bad out of sample predictions. So that's sort of a long explanation of what we're about to let stats models do for us automatically. So we can actually just let stats models say, okay, why don't you try every model up to, lag order 6 and just tell me the best one based on minimum BIC. So we can just let stats models do that for us and save us a lot of programming, because you could program that up yourself, but we let stats models do it. And look at that. They tried every model that they could fit up, up to lag order 6. I'm sure the higher order lags, they weren't able to fit successfully. And so they determined, okay, the model with the minimum BIC is actually the lag order 1. So that's just our first model. What this is this model, but without the ... dots. So we're literally just doing YT on YT minus 1, inflation of T minus 1, the interest rate of T minus 1, and so forth. So we finally get to the goods. So we've got our best model. Let's forecast it and show the data. Maybe I ran that twice. Not certain why it's printing twice. But anywho, here are our forecasts. So this legend's a little in the way, but there's our forecast for our total sales. Here is our forecast for inflation, so slightly rising. And then this is interesting. So our forecast for the interest rate is, negative, but as we know, the interest rate can't be, it can't be nominally below 0. So the Federal Reserve has to use monetary policy, quantitative easing, and other tools in their toolbox to effectively drive the interest rates below 0, if that's what their policy is. So that's the plot. I will admit that I am just now learning the stats models packages, because I would like to actually print out what this series is here, but I am not certain that I know I may need to learn the stats models package a little bit better to actually get you these raw data points here. However, here is the package I'm using, and there is a lot here. So I've just hit the surface. You can do error analysis to make sure you're not doing anything crazy. We've done the lag order selection. And then I think for maybe in the future, I would like to show you how to do impulse response functions, because you can actually say, okay, well, what would actually happen if there was a shock in prices? How would that affect output? Or if there was a shock in the interest rate, how would that affect prices or sales? So all three of these series are theoretically related to each other, particularly sales and prices. So long story short is you can use these impulse response functions to simulate shocks. So like what would happen if all of a sudden there was a recession so these could be useful for simulating harvest spikes in October or something like that. So so perhaps for next week we can dive into that, and I'll actually want to show you the actual numbers here, but that is sort of the conclusion of my my spiel here on forecasting inflation. And so I would just maybe like to open it up if there are any questions or anything. Or were you able to, is that beneficial, or there are avenues for better analysis next week, or?
No, it was interesting. These are things that I don't think about, so it was good to learn about how you go about forecasting these things, and so it was cool. It was I learned something.
Okay. What are some of the things you think about? Because this may have been, I'm not sure, this may have been a bit too, I don't know, economics heavy. So what are some of the things that you're thinking about on a day-to-day basis here?
Well, that's kind of in my data science journey. I realized there's like a data science food pyramid of like things that you should know. And so I know everything at the top and I know everything at the bottom, but there's this middle, like sort of business understanding, business storytelling kind of thing, which I don't know. And so I don't really, I'm just trying to learn that kind of thing. And this is these presentations have been really good for that.
Well, that could also just be my style. So that's sort of, from my experience, that was, so I attended a lot of seminars when I was in college, and that's what I noticed made the most successful presentations / papers is when you sort of tell a story and you let the models evolve. So you start with some sort of business question. So in here we start. It helps to start with just a figure. So start with the data. So we just started with what we're looking at: sales in Oregon, prices in Oregon. And we sort of just let the model evolve naturally. So we start as simple as we can with essentially the growth rate. So you start, with the simplest statistics you can calculate, and then you gradually make it more complex. So really, before you jump to the VAR, you'd really want to just estimate a VAR, which we've kind of done. Well, I'm not sure. I'll have to review it. We may have done that in prior weeks, but essentially you let the model become gradually more complex, but still keeping in mind your initial objective. And then you just and then as you're doing your analysis, you'll be calculating other metrics of interest, right? So we calculated the share of flower, we calculated the share of concentrates. All of those sort of add to the story we're telling here of this presentation. And so you sort of build these pieces here. They're just sort of pieces of your analysis that just gradually you just keep adding to it until you've done sort of an in-depth analysis on the subject at hand, and then you've answered sort of your question at hand, which started by just looking at the data. We just basically wanted to know what's the trajectory for inflation. What even is inflation? So we were able to, gradually build up to that. And then we can answer that question. We can say, oh, it looks like despite, historic deflation in the first 2 years, we predict, moderate inflation. And I wish I could print the numbers and actually give you the number here. But yeah, we predict, moderate inflation here throughout the rest of the year. And you could keep taking this story further and keep adding steps to it. So you could say, oh, like what's going to happen if there's a harvest spike, or what about this, or can't we estimate an even better model? So, and that's where sort of papers build on each other, is because then you kind of can continue someone else's story by saying, oh, picking up this story where they left off, I'm going to, add to their model. But that's my approach, is just start off simple and then just sort of document your steps, instead of just jumping to the end and just saying, oh, I'm just going to do a, principal components analysis, or I'm going to do, machine learning algorithm XYZ, instead of just jumping all the way there. I find it's more informative to start with the basics and then build your way up until the machine learning algorithm is actually like the next reasonable next step. Because eventually, if you kept taking this analysis further and further and further, I mean, machine learning would be the rational next step. I just wouldn't start with it right out of the gates. So that's a long-winded answer, but I resonate with that statement you made.
Yeah, cool. That's I think kind of the lesson that I've been learning, and everybody emphasizes machine learning a lot, but actually there's a lot of steps before you get there and before it's even useful. Recruiter. They never stop calling. But anyway, I read a really cool article in the Oregonian, and I'm trying to figure out how to share it, because the Oregonian is making it more and more difficult to read their articles online and share them. But there was an article about the counties and the towns along the Oregon-Idaho border, and how, because cannabis is legal in Oregon but not in Idaho, that these towns have, like on the weekend, they have huge influxes of people from Idaho coming in, and like the per capita cannabis sales in these towns is like 4 and 5 times the amount it is in like Multnomah County, which is like the most populous county in Oregon.
Oh gosh! Oh, because people are coming in from Idaho.
Coming in, yes, and so and there was a statement from like somebody in New Mexico, and they're like, yeah, we needed to legalize it before Texas does, so that we can capitalize on those sales. So it was really interesting.
And I guess that's one of those things where it's so hard to capture that in the data. And I'm not even sure what the laws on that are. Maybe, but that's up to the individuals who are doing that, I suppose. But
I know there's a town called Ontario, Oregon that's right on the Oregon-Idaho border that has a pretty big dispensary. So, well, has a dispensary. So they're making money from both states.
well, the people in Oregon are just saying, "Hey, we're just opening up shop. What we're not doing anything wrong." So,
Yeah.
I don't know. That's an interesting observation, and that's something to think about, Charles. That if there's any way to parse that out of the data, I don't know if the Oregon data has a geographical like component to it, but I don't know. That may take a bit more exploration. I'm not sure if you can get sales by licensee in Oregon or not, and try to do a geographical analysis.
Well, I mean, whoever wrote this article was able to figure it out. They were able to do like a per capita analysis.
Oh, okay. So they may have county by county data. So you may actually be able to do some sort of analysis there. So that perhaps actually for a future meetup we could do geographical analysis there, because like I said, I think the geographical dimension is an incredibly interesting one. It's can be tricky, but we've got the counties, so I mean, there's no reason why we can't do some sort of analysis.
Yeah, and that Ontario is only like Oregon's only like
So
less than an hour away from Boise, Idaho. So I bet people from Boise are like, because Boise is a college town too. So you're probably having a lot of people from Boise just drive to Ontario to pick up stuff.
that would be a real interesting analysis, and you could extend that to a bunch of states, because that would be interesting to see if you have like this like border phenomena in cannabis states, where of course you would expect like the cities to be like high in sales, but then yeah, it would be so funny if like the border towns were all high sales too.
Yeah.
But that's interesting observation, and could be a good opportunity for analysis.
Yeah.
So I think I'll go ahead and guess, unless anyone's got any more topics at hand to talk about it. I think we've kind of reached the hour. So unless anyone has else to throw on the table, I may go ahead and conclude it here.
Okay.
Until next week.
Okay.
All right. Well, thank you all for coming. Thanks, Ryan. Thanks, Charles. Thanks, Nick.
Yeah.
And thank you for your contributions. It's always awesome to hear from you. And then next week, we'll see if we can't look at Charles's waste data, touch up the inflation data if needed, and then maybe start some geographical
Cool.
analysis of the production, if we can find that county data.
Awesome.
All right, everyone.
Thank you.
See you later.
Thanks for coming. And until next week, have an awesome week.
Yeah. Bye.
Bye now.
Okay, bye.